You wake up, but something's wrong. Terribly wrong. Your eyes snap open in the darkness, and you can see your bedroom, the familiar shapes of your furniture, the glow of your alarm clock. Everything looks normal, except you can't move. Not a finger, not a toe. You try to scream, but no sound comes out. Your throat is frozen. And then you feel it. A presence. Something is in the room with you. Something dark. Something evil. It's watching you. You can sense it moving closer. A shadow darker than the darkness itself creeps toward your bed. You try to move again, desperately thrashing in your mind, but your body refuses to obey. The thing gets closer. You can feel its weight pressing down on your chest, crushing the air from your lungs. You still can't scream. And in that moment of pure primal terror, you realize something that makes it even worse. This isn't the first time, and it won't be the last. If you enjoyed this, hit that like button. Also, 99% of you that watch our videos aren't subscribed, so kindly hit the subscribe button. It helps our video reach more people who enjoy content like this. Welcome to the nightmare that science can explain but can't make any less terrifying. Today, we're diving deep into one of the most disturbing phenomena that the human brain can produce: sleep paralysis demons. And I'm warning you right now, the scientific explanation for why your brain conjures up these horrifying entities might be even more unsettling than the demons themselves. Because unlike ghosts or monsters under your bed, these creatures come from inside your own mind, and they're more common than you think. Let me paint you a picture of what we're dealing with here. Imagine you're lying in bed. Maybe you just fell asleep. Maybe you're about to wake up. Suddenly, you become conscious, but you realize with growing horror that you cannot move a single muscle in your body. Your eyelids might flutter open, and you can see your room, but it's different somehow. The shadows seem deeper, the air feels heavier, and then the hallucinations begin. Maybe you hear footsteps, heavy, deliberate footsteps approaching your bed. Maybe you see a dark figure standing in the corner of your room, watching you with malevolent intent. Maybe you feel something sitting on your chest, pressing down with impossible weight, making it hard to breathe. Some people report seeing old hags with wrinkled faces and yellow eyes. Others see shadow people, figures made of darkness itself. Still others see demons with red eyes, aliens with emotionless faces, or things so bizarre and terrifying that they struggle to describe them even years later. And here's the truly disturbing part. You know you're awake. This isn't like a normal nightmare where part of your brain recognizes that you're dreaming. During sleep paralysis, you are conscious, you are aware, your eyes are open, you can see your actual bedroom, but you cannot move. And the things you're seeing, the things you're feeling, they seem absolutely undeniably real. This is what researchers call a waking nightmare, and roughly 30% of people will experience it at least once in their lifetime, according to research from the Cleveland Clinic. That's almost 1 in 3 people. Think about that. Look at the people around you, your friends, your family, your classmates. Statistically, many of them have experienced this terror, and they might have never told anyone because it sounds too crazy, too impossible to explain. But here's where it gets really interesting. Sleep paralysis isn't some modern phenomenon discovered by neuroscientists in lab coats. Humans have been experiencing this for thousands of years, and throughout history, every culture has tried to explain it in their own way. The ancient Egyptians believed it was a demon called a jinn. In medieval Europe, people thought it was an incubus or succubus, demons that would sit on your chest and suffocate you. The incubus, coming from the Latin word meaning to sit on, was believed to cause horrifying dreams and physical immobility. That's actually where we get the word nightmare from. The Old Norse cultures had the Mara, an evil spirit that would torment sleepers. In Japan, they have the kanashibari, which translates to bound by metal. In Newfoundland, Canada, people call it the old hag. In Turkey, it's called karabasan, the dark presser. Chinese culture refers to it as being pressed by a ghost. But here's what's absolutely mind-blowing. Despite these cultures being separated by thousands of miles and thousands of years, the descriptions are remarkably similar. A dark presence, something pressing on the chest, the inability to move or scream, overwhelming terror. How is that possible? How can people who never met, who lived in completely different times and places, describe essentially the same experience? The answer lies in the architecture of the human brain itself, and it's far stranger than any demon or ghost story. Let's start with the basics, because understanding what's happening during sleep paralysis requires understanding how your brain handles sleep in the first place. Every night when you drift off to sleep, your brain cycles through different stages. You've probably heard of REM sleep, which stands for rapid eye movement sleep. This is the stage where most of your vivid dreams occur. And during REM sleep, something fascinating and crucial happens. Your brain essentially paralyzes your body. Seriously, every night, multiple times, your brain sends signals that shut down most of your voluntary muscles. Scientists call this REM atonia. The word atonia literally means without muscle tone. Why does your brain do this? Think about it. During REM sleep, you're having vivid, often intense dreams. You might be running from something, fighting, or performing complex actions. If your muscles weren't paralyzed, you'd actually act out these dreams in real life. You'd be flailing around, potentially hurting yourself or anyone sleeping next to you. Your brain has evolved this incredible safety mechanism to keep you still while your mind goes on wild adventures. Research published in recent studies has shown that two powerful brain chemical systems work together to create this paralysis. The pons and the ventromedial medulla, structures deep in your brainstem, use neurotransmitters called GABA and glycine to suppress skeletal muscle activity during REM sleep. Basically, these chemicals tell your spinal motor neurons to shut down, freezing your body in place. Now here's where things go wrong. Sleep paralysis happens when your brain wakes up, but the paralysis system doesn't shut off. According to research published in the journal Frontiers in Neuroscience and the National Center for Biotechnology, during sleep paralysis, your brain transitions out of REM sleep into wakefulness before the body paralysis stops. Your consciousness returns. You become aware. You can think. You can see. But your muscles are still locked down by those same chemicals that were meant to protect you during dreams. You're essentially trapped in your own body, caught between sleeping and waking, experiencing what neuroscientists call a dissociated state. And this is where your brain starts to panic. Because here's something most people don't realize. Your brain is constantly trying to make sense of the world. It's always looking for explanations, always trying to create a coherent narrative from the sensory information it receives. When you suddenly find yourself awake but unable to move, your brain recognizes that something is very wrong. And it does what human brains have evolved to do for millions of years. It assumes you're in danger. Enter the amygdala, a small almond-shaped structure deep in your brain that serves as your threat detection system. The amygdala is like your brain's smoke alarm, always on the lookout for danger. Research published in medical journals has shown that during sleep paralysis, the amygdala becomes overactive. It's firing alarm signals throughout your brain, flooding your system with fear and anxiety. Your amygdala is screaming that you're in terrible danger, that you need to move, that you need to escape. But you can't move. And this creates a horrifying feedback loop. The fear makes your heart race, your breathing becomes rapid and shallow. You try harder to move, but the paralysis holds firm. This makes you more afraid. The fear intensifies. The cycle escalates. But wait, there's more. During this dissociated state between sleep and wakefulness, something else bizarre happens. Parts of your brain are still in dream mode. The visual cortex, the parts of your brain responsible for processing what you see, is still partially in that REM sleep state where it generates dream imagery. So you're awake, your eyes are open, you can see your real bedroom, but your visual cortex is also overlaying dream images on top of your actual vision. It's like having two realities superimposed on top of each other: your real bedroom and the nightmare your brain is generating. And because your amygdala is screaming danger, because your threat detection system is in full alarm mode, what kind of images do you think your brain produces? Happy puppies? Rainbows? Of course not. Your brain generates images that match the intense fear you're feeling. Dark figures, threatening presences, monsters, demons. Your brain is literally creating visual hallucinations.
That's why I'm terrified. The hallucination isn't random. It's your brain's attempt to make sense of the physical sensations you're experiencing. But the hallucinations don't stop with just visual images. Remember that feeling of pressure on your chest that so many people report? That crushing weight, like something is sitting on you, making it hard to breathe? That's not imagination either. During REM sleep, your breathing is naturally irregular. Your intercostal muscles, the muscles between your ribs that help you breathe, are partially paralyzed during REM sleep, just like your other muscles. When you wake up into sleep paralysis, you become consciously aware of your breathing while these muscles are still partially paralyzed. You're trying to take deep breaths, but your body isn't responding normally. This creates a sensation of chest pressure, of difficulty breathing, of being suffocated. And once again, your brain tries to explain this sensation. Why do I feel pressure on my chest? Why can't I breathe properly? The answer it generates is, something must be pressing on me. Something must be sitting on my chest, crushing me. And then your visual cortex obliges by creating an image to match that explanation. A dark figure, a demon, an old hag, sitting right there on your chest staring at you with malevolent intent. Research has also identified what scientists call the intruder, incubus, and unusual bodily experiences, the three main categories of sleep paralysis hallucinations. The intruder type involves sensing a threatening presence, seeing or hearing something dangerous in the room. This correlates with hyperactivity in the parts of your brain involved in threat detection. The incubus type involves the chest pressure, difficulty breathing, and often sexual or suffocation experiences. This correlates with the breathing irregularities and muscle paralysis. The unusual bodily experiences include feelings of floating, out-of-body experiences, or feeling like you're spinning or falling. These correlate with disruptions in how your brain processes sensory information about your body's position in space. Now here's something that makes it even creepier. Research has found a genetic component to sleep paralysis. That's right, if your parents experienced sleep paralysis, you're more likely to experience it too. The tendency toward the characteristic fragmentation of REM sleep and these types of hallucinations can be inherited. It's literally in your DNA. Scientists believe that the same genes that make you susceptible to other parasomnias, sleep disorders where unusual behaviors occur during sleep, also make you more likely to experience sleep paralysis. But genetics aren't the only factor. Environmental and lifestyle factors play a huge role too. A systematic review that looked at 42 different studies on sleep paralysis found several common themes among people who experience it regularly. And this is important because it means that even if you're genetically predisposed, you might be able to reduce your risk by changing certain behaviors. First, sleep deprivation is a massive trigger. When you don't get enough sleep, when you're chronically exhausted, your brain's normal sleep cycles get disrupted. The transitions between different sleep stages become unstable. You're more likely to have these dissociated states where part of your brain is awake while another part is still asleep. College students, shift workers, people with newborn babies, anyone who's regularly sleep deprived is at higher risk. Your brain is desperate for that REM sleep it's been missing, so when you finally do sleep, it tries to dive straight into REM. This can cause what scientists call REM rebound, where you enter REM sleep too quickly, increasing the chances of waking up while still paralyzed. Second, irregular sleep schedules wreak havoc on your brain's sleep architecture. Your brain loves routine. It has internal clocks, circadian rhythms, that regulate when you should be asleep and awake. When you're constantly changing your sleep schedule, going to bed at wildly different times, sleeping during the day and being awake at night, your brain gets confused. The normal progression through sleep stages gets disrupted, and you're more likely to experience sleep paralysis. Third, stress and anxiety are huge triggers. And this makes sense when you think about it. Remember that overactive amygdala we talked about? If you're already stressed, if you're already anxious, your amygdala is already on high alert even before you go to sleep. It's primed to detect threats. So when sleep paralysis occurs, when your brain recognizes something is wrong, that already hyperactive threat detection system goes into overdrive even faster. The fear response is more intense. The hallucinations are more vivid and terrifying. Fourth, sleeping on your back increases your risk. Multiple studies have found that people are significantly more likely to experience sleep paralysis when sleeping in the supine position, flat on their back. Scientists aren't entirely sure why this is, but they have some theories. Sleeping on your back might make breathing irregularities during REM sleep more pronounced. It might also make you more likely to partially wake up during REM sleep. Whatever the reason, if you're prone to sleep paralysis, sleeping on your side might reduce your episodes. Fifth, certain mental health conditions are associated with higher rates of sleep paralysis. People with anxiety disorders, panic disorder, PTSD, and depression report sleep paralysis more frequently than the general population. This could be because these conditions often involve disrupted sleep patterns, hyperactive threat detection systems, and dysregulation of the same neurotransmitters involved in sleep paralysis. It could also work the other way. Experiencing terrifying sleep paralysis episodes repeatedly could contribute to developing anxiety or PTSD-like symptoms. It's a complex relationship that researchers are still working to understand. Sixth, narcolepsy has a strong connection to sleep paralysis. Narcolepsy is a neurological disorder that causes excessive daytime sleepiness and disrupts the normal boundaries between sleep and wakefulness. People with narcolepsy experience frequent transitions between waking and sleeping states, and their REM sleep intrudes into wakefulness more often. As a result, roughly 60% of people with narcolepsy report regular sleep paralysis episodes. For them, sleep paralysis is not just an occasional terrifying experience, it's a regular feature of their condition. Now let's talk about something really disturbing: the cultural interpretation of sleep paralysis and how it can actually make the experience worse. Remember how I mentioned that different cultures throughout history have had different names and explanations for sleep paralysis? Well, research has shown that what you believe about sleep paralysis actually affects how you experience it. In a fascinating study, researchers compared sleep paralysis experiences in Egypt and Denmark. In Egypt, where there are strong cultural beliefs about evil spirits and supernatural entities, people who experience sleep paralysis reported much more intense fear and much more terrifying hallucinations compared to people in Denmark, where there's less cultural emphasis on supernatural explanations. Think about what this means. If you grow up hearing stories about demons that attack people in their sleep, if you're culturally primed to interpret sleep paralysis as a supernatural attack, when you experience it, your brain has a ready-made explanation. A demon is attacking me. This interpretation triggers even more fear, which creates more intense hallucinations, which reinforces your belief that you're being attacked by something supernatural, which creates even more fear. It's a vicious cycle where your cultural beliefs and your brain's threat response feed into each other, making the experience worse. On the other hand, if you understand the science, if you know that what you're experiencing is a temporary glitch in your sleep cycle, if you recognize that the demon you're seeing is a hallucination generated by your own brain, you can potentially reduce the fear response. You can tell yourself, this is sleep paralysis. This isn't real. My brain is playing tricks on me. This will pass in a few minutes. That understanding, that cognitive reframing, can interrupt the fear cycle and make the experience less intense. But here's the thing. Even when you know intellectually what's happening, even when you understand the neuroscience, sleep paralysis is still absolutely terrifying. Because in that moment, when you're paralyzed, when you can see that dark figure approaching your bed, when you can feel that weight on your chest, your amygdala doesn't care about neuroscience. Your threat detection system is screaming that you're in mortal danger. The fear feels absolutely real, because, to your brain, it is real. Let me share some real accounts of sleep paralysis to give you an idea of what people actually experience. These are anonymized stories collected by researchers, but they represent the three main types of sleep paralysis hallucinations we discussed earlier. One person described waking up unable to move and seeing a tall, dark shadow figure standing at the foot of their bed. The figure had no face, just a void where a face should be, but they could feel it watching them with intense malevolence. They tried to scream for help, but no sound would come out. The figure slowly moved closer, and they could feel waves of evil radiating from it. After what felt like an eternity, but was probably only 2 or 3 minutes, they were suddenly able to move again. The figure vanished instantly. They jumped out of bed, turned on all the lights, and didn't sleep for the rest of the night.
They were terrified to go to sleep. Another person reported a different type of experience. They woke up feeling like someone or something was sitting directly on their chest. They couldn't move, couldn't breathe properly, and felt an overwhelming sense of doom. They heard breathing, not their own, right next to their ear. They could feel hot breath on their neck. They sensed, rather than saw, something crouched on their chest, something heavy and malicious. They tried desperately to push it off, but their arms wouldn't move. They thought they were going to suffocate. Then, as suddenly as it began, the weight lifted. They gasped for air, their heart pounding so hard they thought they might have a heart attack. A third person described an out-of-body experience. They became aware that they couldn't move, but then they felt themselves floating up out of their body. They could see themselves lying in bed below. But the experience wasn't peaceful. There was a loud buzzing sound, like a swarm of bees or electrical static. They felt like they were being pulled or dragged by something they couldn't see. They tried to get back into their body but couldn't. They felt trapped in this weird in-between state, terrified that they might not be able to get back, that they might be stuck like this forever. Eventually, they felt themselves slam back into their body, and they could move again. These aren't ghost stories. These aren't supernatural encounters. These are real people describing real neurological events. Their brains, caught in that dissociated state between sleep and wakefulness, generated these vivid, terrifying hallucinations. And the hallucinations felt completely, utterly real. Now let's talk about some even weirder aspects of sleep paralysis that scientists are still working to fully understand. Some people report recurring sleep paralysis with the same entity appearing over and over. They'll see the same shadowy figure, the same demon, the same presence every single time they experience sleep paralysis. Sometimes they even give it a name. They start to anticipate it, to recognize it. How is this possible if it's just a hallucination generated randomly by a malfunctioning sleep system? Researchers believe this happens because of how memory works. Your brain is incredibly good at pattern recognition. Once you've experienced sleep paralysis and your brain generated a particular type of hallucination, that experience gets encoded into your memory. The next time you experience sleep paralysis, your brain, searching for an explanation for the paralysis and fear, accesses that memory. It essentially says, "Oh, I know what this is. It's that thing again, that presence, that demon." And it reconstructs a similar hallucination based on your memory of the previous episode. Over time, with repeated episodes, the hallucination becomes more stable, more consistent. You're not seeing the same demon because that demon is real and stalking you. You're seeing the same demon because your brain has learned that this is what it's supposed to generate during sleep paralysis. This also explains why sleep paralysis hallucinations are so culturally specific. Your brain draws on your cultural knowledge, your fears, your expectations when it constructs these hallucinations. If you grew up watching horror movies about aliens, you might see aliens during sleep paralysis. If you grew up hearing stories about ghosts, you might see ghosts. If you grew up in a religious environment with concepts of demons and evil spirits, you might see demons. Your brain is using the templates it has available, the imagery stored in your memory, to create an explanation for what you're experiencing. Some researchers have even proposed that many historical reports of supernatural encounters might actually have been sleep paralysis. The Salem witch trials in colonial Massachusetts? Some historians now believe that many of the accusations of witchcraft, where people reported being visited by spectral figures that paralyzed and tormented them, might have been sleep paralysis experiences interpreted through the lens of that culture's belief in witchcraft. Alien abduction experiences? A significant number of reported alien abductions involve waking up paralyzed with strange beings in the room, followed by a sense of floating or being moved. These descriptions match sleep paralysis hallucinations almost perfectly. This doesn't mean that everyone who reports a supernatural experience is experiencing sleep paralysis, but it does suggest that this neurological phenomenon has been shaping human culture, religion, and mythology for thousands of years. Before we understood the science, before we could peek inside the brain and see what was happening, humans naturally interpreted these experiences in supernatural terms. And those interpretations became embedded in our folklore, our religions, our collective understanding of the world. Let's talk about the serotonin connection, because this is where things get really interesting from a neurochemical perspective. Research published in the journal Psychopharmacology has shown that serotonin 2A receptors, which are found throughout your brain, play a crucial role in sleep paralysis hallucinations. These same receptors are activated by hallucinogenic drugs like LSD and psilocybin, the active compound in magic mushrooms. When these receptors are activated, they can produce visual hallucinations, feelings of mystical experiences, out-of-body sensations, and alterations in fear circuits. Sound familiar? During sleep paralysis, researchers believe that disruptions in serotonin signaling, particularly involving these 2A receptors, contribute to the vivid hallucinations people experience. In a sense, your brain is temporarily producing its own hallucinogenic experience without any external drugs. The same neurotransmitter systems that can be artificially activated by psychedelic drugs are being naturally activated in a dysregulated way during sleep paralysis. This is why sleep paralysis hallucinations can be so intense, so vivid, so real-feeling. Your brain is in a genuine altered state of consciousness, similar in some ways to a drug-induced hallucination, except it's triggered by a malfunctioning in your sleep cycle rather than by ingesting a substance. This also explains why some of the stranger aspects of sleep paralysis, like out-of-body experiences, feelings of cosmic significance, or encounters with seemingly intelligent entities, mirror experiences reported by people using psychedelic drugs. The brain mechanisms are similar. Both involve alterations in how your brain processes sensory information, how it constructs your sense of self, and how it generates conscious experience. Now, let's address something important. If sleep paralysis is so common, affecting up to 30% of people at some point, why don't we talk about it more? Why do so many people who experience it feel alone, feel crazy, feel like they can't tell anyone? The answer is complicated. First, there's the nature of the experience itself. How do you explain to someone that you woke up, couldn't move, and saw a demon in your room? It sounds unbelievable. It sounds like something from a horror movie. People worry that others will think they're making it up, that they're mentally unstable, or that they're seeking attention. Second, there's the fact that sleep paralysis episodes are usually brief. They typically last anywhere from a few seconds to a few minutes. Once they're over, you can move again, the hallucinations vanish, and you're left lying in your bed in a normal bedroom with no physical evidence that anything happened. There's no monster to point to, no physical harm to show. Just your own memory of an incredibly terrifying experience. And as time passes, as the immediate fear fades, it starts to feel almost unreal. Did that really happen? Was it just a weird dream? Third, until relatively recently, there wasn't widespread public knowledge about sleep paralysis. It wasn't something you learned about in school, it wasn't commonly depicted in media.
If you experienced it and didn't happen to research it or talk to a knowledgeable doctor, you might never discover that what you experienced has a name, that it's a recognized medical phenomenon, that millions of other people have experienced the exact same thing. Fortunately, that's changing. As more people share their experiences online, as more scientists study the phenomenon, as more content like this video spreads awareness, people are starting to realize they're not alone. That realization can be incredibly powerful. The fear and confusion that comes with sleep paralysis is often made worse by the sense of isolation, by feeling like you're the only person this has ever happened to. Learning that it's common, that it's well documented, that there's a scientific explanation, doesn't make the experience pleasant, but it can make it less traumatizing. So, what can you do if you experience sleep paralysis? How can you reduce your risk, and what should you do if you find yourself trapped in that paralyzed state? Let's start with prevention. Remember those risk factors we discussed. Many of them are modifiable, meaning you can change them. Get enough sleep. Aim for 7 to 9 hours per night consistently. Don't skimp on sleep during the week thinking you'll make it up on weekends. Your brain needs regular, adequate sleep to maintain healthy sleep cycles. Maintain a consistent sleep schedule. Go to bed at roughly the same time every night, wake up at roughly the same every morning. Yes, even on weekends. Your brain's circadian rhythms thrive on consistency. Try to sleep on your side instead of your back. Studies suggest this reduces sleep paralysis frequency, though scientists aren't entirely sure why. Manage stress and anxiety. Easier said than done, I know, but finding healthy ways
To cope with stress, whether through exercise, meditation, therapy, or hobbies, can reduce your overall anxiety levels and make your amygdala less hyperactive. Avoid caffeine and alcohol close to bedtime. Both can disrupt your sleep architecture and increase the likelihood of unusual sleep experiences. Create a relaxing bedtime routine. Give your brain time to wind down before sleep. Avoid screens, intense exercise, or stressful activities right before bed. Address any underlying sleep disorders. If you snore heavily, if you stop breathing during sleep, if you have restless legs, get these issues checked out. Sleep apnea and other sleep disorders can fragment your sleep and increase sleep paralysis risk. But what if prevention doesn't work? What if you find yourself in the middle of a sleep paralysis episode, paralyzed and terrified? Here's what sleep researchers and people who've experienced recurrent sleep paralysis recommend. First, remind yourself that it's temporary. Sleep paralysis episodes are brief. They will end. You will be able to move again. You are not dying. You are not being attacked. Your brain is experiencing a temporary glitch. This is easier said than done when you're terrified, but even just trying to hold on to this thought can help reduce panic. Second, focus on small movements. You might not be able to move your whole body, but sometimes you can move your fingers or toes. Some people find that if they focus all their effort on wiggling one finger, they can eventually break the paralysis. Others focus on trying to move their eyes or change their breathing pattern. These small movements can sometimes help your brain realize it's time to fully wake up. Third, try to stay calm and breathe steadily. Panicking and trying to thrash around mentally only increases your fear, which strengthens the hallucinations and prolongs the episode. If you can manage it, try to take slow, steady breaths. Accept that you're temporarily paralyzed. Stop fighting it. Paradoxically, accepting the paralysis and staying calm often causes the episode to end faster than fighting it does. Fourth, close your eyes if possible. If you can still control your eyelids, closing your eyes might reduce the intensity of visual hallucinations. You might still sense a presence, but not seeing it can make the experience less terrifying. Fifth, try to remind yourself that anything you're seeing or sensing is a hallucination. That demon isn't real. That shadow figure isn't real. It's your brain generating imagery. This cognitive reframing, acknowledging that your perceptions are not matching reality, can help reduce the fear response. Some people who experience frequent sleep paralysis have developed their own coping techniques. One person described imagining themselves sinking into the bed rather than fighting the paralysis, essentially surrendering to the experience.
They found that this mental shift often caused the paralysis to end more quickly. Another person described trying to think of pleasant things, reciting song lyrics in their head, anything to distract their mind from focusing on the fear. These aren't scientifically proven techniques, but they work for some individuals. If you experience sleep paralysis frequently, if it's significantly impacting your quality of life, if you're developing anxiety about going to sleep, it's worth talking to a doctor. While sleep paralysis itself isn't dangerous, it can be a symptom of underlying sleep disorders like narcolepsy. A sleep specialist can evaluate your sleep patterns, possibly conduct a sleep study, and determine if there are underlying issues that need to be addressed. In some cases, if sleep paralysis is severe and recurrent, medications that alter REM sleep or affect neurotransmitter systems can be helpful, but this should only be done under medical supervision. Now, let's talk about something that might seem contradictory. Some researchers and some people who've experienced sleep paralysis suggest that with practice and the right mindset, sleep paralysis can actually be transformed into a less frightening or even positive experience. This is controversial and definitely not easy, but hear me out. Remember, the terrifying aspects of sleep paralysis, the demons, the sense of danger, come from your amygdala's threat response and your brain's attempt to explain why you're paralyzed. But what if you could train your brain to interpret the situation differently? Some lucid dreamers, people who've learned to become conscious during their dreams and control them, report that sleep paralysis can be a gateway to lucid dreams. The idea is that if you remain calm during sleep paralysis, if you don't fight it but instead relax into it, you can sometimes transition into a conscious dream state. Instead of panicking about the paralysis, you accept it. Instead of interpreting the strange sensations as threatening, you reinterpret them as interesting. This is extremely difficult and takes practice, but some people report success with this approach. Similarly, some people who've experienced sleep paralysis many times report that it becomes less frightening over time. Not because it becomes less intense, but because they've learned what it is. They've learned that it will pass. They've learned that the demons aren't real. Their amygdala still activates, but their prefrontal cortex, the thinking part of their brain, can provide context and reduce the panic response. One person described it like watching a scary movie. The first time you watch it, you're terrified. But if you watch the same scary movie 10 times, even though you know it's scary, even though the same frightening scenes happen, you're less scared because you know what to expect. You know it's not real. You know it will end. This doesn't work for everyone, and I'm not suggesting that sleep paralysis can or should be embraced as a positive experience. For many people, it remains terrifying no matter how many times they experience it. But understanding that your fear response is something that can potentially be modified, that your brain's interpretation of the experience isn't fixed and unchangeable, can be empowering for some people. Let's circle back to something fundamental. Why does the human brain do this? From an evolutionary perspective, why would we have a system that can produce such a terrifying, seemingly maladaptive experience? The answer is that sleep paralysis itself isn't the adaptation. REM atonia, the muscle paralysis during REM, is the adaptation. It evolved to keep us safe during dreaming, preventing us from acting out our dreams and potentially injuring ourselves. Sleep paralysis is simply what happens when that system glitches, when the timing gets off, when you wake up before the paralysis has ended. In evolutionary terms, this kind of glitch is relatively harmless. Yes, it's terrifying. Yes, it's unpleasant, but it doesn't cause physical harm. It doesn't reduce your ability to survive and reproduce. It's just a temporary malfunction of a system that's normally very useful. Evolution doesn't optimize for comfort or pleasant experiences. It optimizes for survival and reproduction. As long as sleep paralysis doesn't kill you or prevent you from having children, evolution doesn't particularly care that it's scary. But here's where it gets interesting. That hyperactive threat detection system, that overactive amygdala that creates the sense of danger and conjures up threatening hallucinations, that system was actually very useful for most of human evolutionary history. For millions of years, humans lived in environments where real threats were common. Predators, hostile neighboring groups, dangerous animals. Our ancestors who had sensitive threat detection systems, who were quick to assume danger, who saw threats even when they weren't always there, those were the ancestors who survived. It was better to mistake a shadow for a predator 100 times than to mistake a predator 100 once. That one mistake could kill you. So, we inherited brains that are biased toward detecting threats, that are quick to generate fear responses that create vivid mental images of potential dangers. Dark figures, attackers, predators, things that want to harm us. Your sleep paralysis demons are, in a sense, evolutionary ghosts. They're your brain using ancient survival mechanisms in a modern context where those mechanisms aren't needed. They're the price we pay for having a threat detection system that kept our ancestors alive but is now sometimes too sensitive, too ready to sound the alarm. Now, let's talk about some of the weirder scientific findings about sleep paralysis that really push the boundaries of what we understand about consciousness and the brain. In studies where researchers have interviewed hundreds of people about their sleep paralysis experiences, they've found some fascinating patterns. One is that sleep paralysis hallucinations often include specific sensory details that seem too consistent to be coincidence. People report hearing specific sounds, footsteps with a particular rhythm, breathing with a particular quality, voices with particular characteristics. One theory is that during sleep paralysis, your brain is in a hyper-aware state. Your sensory systems are heightened because your amygdala is screaming that you're in danger. So you might be hearing real sounds, the hum of an air conditioner, the settling of your house, distant traffic, but your brain is interpreting
these sounds through the lens of threat. That air conditioner hum becomes breathing. The house settling becomes footsteps. The distant sound of a truck becomes a growl or a voice. Your brain is taking real sensory input and filtering it through a threat detection lens, transforming neutral stimuli into frightening interpretations. Another weird finding is that some people report feeling like the entity they perceive during sleep paralysis has intentions, has intelligence, has a personality. They don't just see a vague shadow. They perceive that the shadow is angry, or that it's curious, or that it's specifically targeting them. They feel like they can sense its emotions or its thoughts. How is this possible if it's just a hallucination? The answer lies in how your brain processes social information. Humans have incredibly sophisticated brain systems dedicated to understanding other minds, to inferring intentions, to reading emotions, to predicting what other people are thinking or feeling. These systems, located primarily in areas like the temporal parietal junction and the medial prefrontal cortex, are what allow you to navigate the complex social world. When you see another person, you don't just see a physical body. You automatically, unconsciously, infer that they have thoughts, feelings, goals, and intentions. You read their facial expressions and body language. You make predictions about what they're going to do next. You empathize with their emotions. These are all unconscious processes that happen automatically. During sleep paralysis, these same social cognition systems can activate, even though there's no real person present. Your brain generates a hallucination of a figure, and then your social cognition systems immediately start treating that figure as if it's a real agent with thoughts and intentions. You start inferring its emotional state. You start predicting what it's going to do. You start feeling like it's watching you, thinking about you, planning something. This is why sleep paralysis entities feel so real, so present, so intentional. Your brain isn't just generating a visual image, it's generating a complete social agent using the same systems it uses to process real people. This also explains why sleep paralysis experiences can feel so personal, so targeted. The entity isn't just there, it's there for you. It's focused on you. It knows you. This isn't because there's any actual entity with knowledge or intentions. It's because your brain's social cognition systems are projecting agency, intentionality, and awareness onto a hallucination. Your brain is doing what it evolved to do, treating anything that looks remotely like an agent as if it is an agent. Because for most of human history, it was safer to over-attribute agency than to under-attribute it. Let's talk about the relationship between sleep paralysis and other altered states of consciousness, because this gets really fascinating. Researchers have noticed that sleep paralysis shares features with several other phenomena. Near-death experiences, for example, often include elements similar to sleep paralysis. The sense of leaving your body, moving through a tunnel,
encountering entities or presences, feeling paralyzed, experiencing intense emotions. Some researchers have proposed that some near-death experiences might actually be related to similar disruptions in consciousness, similar dissociated states where different parts of the brain are activated or deactivated in unusual ways. Similarly, some mystical or religious experiences share features with sleep paralysis: the sense of a powerful presence, feelings of awe or terror, visual hallucinations of entities, out-of-body sensations, feelings of profound significance. This has led some neuroscientists to propose that certain mystical experiences throughout history might have been related to altered states of consciousness, involving similar brain mechanisms as sleep paralysis. This doesn't diminish the significance or meaning that people find in such experiences, but it does suggest that the human brain has specific ways of generating these kinds of experiences, and those mechanisms can be activated in different contexts. There's also overlap between sleep paralysis and certain drug experiences, as we mentioned earlier with the serotonin connection. But beyond serotonin, there are other neurotransmitter systems involved. Dopamine, which is crucial for processing salience, for determining what's important or meaningful, appears to be dysregulated during sleep paralysis. This might explain why sleep paralysis experiences feel so significant, so meaningful, so important. Your brain's dopamine system is tagging the experience as highly salient, which makes it feel profound and memorable. Acetylcholine, a neurotransmitter crucial for REM sleep and for generating vivid dream imagery, is also involved. During REM sleep, acetylcholine levels are very high, which contributes to the intense, vivid quality of dreams. During sleep paralysis, you're in a state that has features of both REM and wakefulness, so acetylcholine levels might still be elevated, contributing to the vivid dreamlike quality of the hallucinations, even though you're consciously aware. All of this points to something profound about human consciousness: the boundary between waking and dreaming, between reality and hallucination, between self and other. These boundaries that seem so solid and clear in our everyday experience are actually maintained by incredibly complex brain systems. And when those systems malfunction, even briefly, the boundaries can dissolve. You can be awake and dreaming at the same time. You can see things that aren't there. You can feel presences that don't exist. You can lose the sense of control over your own body. Sleep paralysis is a window into the constructed nature of consciousness itself. Everything you experience, your sense of being awake, your sense of your body, your perception of the space around you, your feeling of being in control, all of these are actively constructed by your brain. They feel effortless and automatic, but they're actually the product of incredibly complex neural processes. Sleep paralysis reveals what happens when some of those processes keep working while others shut down, creating a bizarre hybrid state that doesn't match any normal category of experience. Let's talk about the psychological aftermath of sleep paralysis, because for some people, a single terrifying episode can have lasting effects. Research has shown that people who experience intense sleep paralysis, especially if they don't understand what's happening, can develop anxiety disorders, particularly anxiety about sleep itself. They become afraid to go to bed. They lie awake worrying that it will happen again. This creates a vicious cycle because sleep deprivation increases the likelihood of sleep paralysis, which increases anxiety, which causes more sleep deprivation, which causes more sleep paralysis. Some people develop what researchers call clinophobia, fear of beds or going to bed. Others develop insomnia, lying awake for hours because they're too afraid to fall asleep. Still others develop nighttime rituals or safety behaviors. They sleep with lights on, they keep the TV on, they check under the bed and in the closets. They sleep with weapons nearby. These behaviors make logical sense if you believe you're being attacked by something real, but they reinforce the idea that sleep is dangerous, which maintains the anxiety. The traumatic nature of sleep paralysis shouldn't be underestimated. Imagine experiencing something that feels like a life-threatening attack, where you're completely helpless, where you genuinely believe you might die, where you see and feel things that seem absolutely real. Now imagine that happening in your own bedroom, the place that's supposed to be your safe space. For some people, particularly those who experience it repeatedly, sleep paralysis can be genuinely traumatizing. They may develop symptoms similar to post-traumatic stress disorder, intrusive memories of the experience, hypervigilance at night, avoidance of sleep. This is why education and understanding are so crucial. When people understand that sleep paralysis is a neurological phenomenon, not a supernatural attack, it can significantly reduce the psychological impact. It doesn't make the experience pleasant, but it makes it less traumatizing. Instead of thinking, I was attacked by a demon and it might happen again, you can think, my brain had a temporary malfunction and it might happen again, but it's not dangerous. That shift in interpretation makes a huge difference in how you cope with the experience. Now, let's address something that comes up frequently in discussions about sleep paralysis. Can it kill you? The short answer is no. Sleep paralysis itself cannot kill you. Your breathing continues, your heart continues beating, and the episode is temporary. However, the fear and stress can certainly feel dangerous. Your heart rate increases, your blood pressure rises, you hyperventilate. For someone with a pre-existing heart condition, this stress could theoretically be problematic, but there are no documented cases of someone dying directly from sleep paralysis. However, there is a related phenomenon that's worth mentioning. In some Southeast Asian cultures, there have been reports of sudden unexplained nocturnal death syndrome, where apparently healthy young men die suddenly in their sleep. Initially, some researchers wondered if this might be related to sleep paralysis, if the extreme fear could somehow cause cardiac arrest. However, further investigation revealed that these deaths are actually caused by Brugada syndrome, a genetic heart condition that causes dangerous heart rhythms during sleep. It's unrelated to sleep paralysis, but the cultural overlap, the fact that these
Sleep happened during sleep and were initially mysterious, led to some confusion. The point is, sleep paralysis feels dangerous. It feels life-threatening, but it's not. Your brain is experiencing a malfunction, but your body is actually fine. You're breathing, your heart is beating, the paralysis will end. Reminding yourself of this during an episode is difficult but important. Let's talk about some of the cutting-edge research being done on sleep paralysis right now. Scientists are using advanced brain imaging techniques like functional MRI and EEG to study what's actually happening in the brain during sleep paralysis. These studies are difficult because sleep paralysis is unpredictable, it happens spontaneously, and it only lasts a few minutes. You can't just put someone in an MRI machine and wait for it to happen. But researchers have developed clever techniques. Some studies recruit people who experience frequent sleep paralysis and have them sleep in the lab with EEG electrodes attached to their head. When an episode occurs, they signal to the researchers, and the brain activity during the episode is recorded. These studies have confirmed that during sleep paralysis, there's a unique pattern of brain activity. Parts of the brain associated with REM sleep are still active, particularly areas involved in generating vivid imagery. But parts associated with wakefulness are also active, particularly areas involved in conscious awareness. Meanwhile, motor cortex activity is suppressed, corresponding to the paralysis. Other researchers are investigating whether sleep paralysis might be related to other neurological conditions. There appears to be a higher prevalence of sleep paralysis among people with anxiety disorders, PTSD, panic disorder, and narcolepsy. Understanding the neurological connections between these conditions could help develop better treatments. Some researchers are exploring whether medications that affect neurotransmitter systems, particularly those involving serotonin, GABA, or acetylcholine, might be able to prevent or reduce sleep paralysis episodes in people who experience them frequently. There's also fascinating research into the genetic basis of sleep paralysis. Twin studies have shown that if one identical twin experiences sleep paralysis, the other twin has a significantly higher chance of experiencing it compared to fraternal twins. This suggests that there are genetic factors that make some people more susceptible. Researchers are working to identify specific genes involved, which could eventually lead to better understanding of the underlying mechanisms and potentially new treatment approaches. Some researchers are even exploring whether virtual reality might be used as a treatment for sleep paralysis-related anxiety. The idea is that by recreating elements of the sleep paralysis experience in a controlled, safe environment, people could be gradually desensitized to the fear. They could practice coping techniques, could learn to recognize that the experience isn't dangerous, all while knowing they can remove the VR headset at any time. This is still very experimental, but early results have been promising for some individuals.
Another area of cutting-edge research involves the relationship between sleep paralysis and creativity. Some researchers have noticed that artists, writers, and creative individuals report sleep paralysis slightly more frequently than the general population. This might be because the same brain characteristics that allow for vivid imagination and creative thinking, the ability to generate rich mental imagery, sensitivity to internal mental states, might also make someone more prone to intense hallucinatory experiences during sleep paralysis. Some artists have actually used their sleep paralysis experiences as inspiration for creative works, transforming their terrifying experiences into art, music, or literature. This connects to a broader philosophical question. What can sleep paralysis teach us about the nature of reality and perception? During sleep paralysis, you have an experience that feels absolutely, completely real. You see entities with your eyes open, you feel sensations in your body, you hear sounds, you sense presences. Every bit of it feels as real as normal waking experience. But it's not real. It's a hallucination generated by your brain. So how do you know that your normal waking experience is any more real? How do you know that what you're perceiving right now as you listen to this video is any more accurate than what someone perceives during sleep paralysis? The answer is consistency and coherence. Your normal waking experience is consistent. Other people can verify what you're seeing. Your experiences fit together into a coherent narrative. Sleep paralysis hallucinations, on the other hand, are temporary, they're inconsistent with normal reality, they end when the episode ends, and other people can't perceive what you're perceiving. But on a fundamental level, both are constructions of your brain. Both are your brain interpreting signals and creating a conscious experience. This raises profound questions about consciousness, about the nature of reality, about what it means to perceive something. Sleep paralysis is, in a way, proof that your brain can create experiences that feel entirely real but correspond to nothing in the external world. It's a demonstration of the brain's creative power, its ability to generate conscious experience. And it's a reminder that everything you experience is filtered through the machinery of your brain. There is no direct, unmediated access to reality. Everything is interpreted, constructed, created by neural processes. For most people, most of the time, those neural processes work smoothly and create experiences that accurately reflect the world. But sleep paralysis shows us what happens when the machinery glitches, when the construction process goes wrong, when the brain creates an experience that doesn't match reality. It's both terrifying and fascinating, a glimpse behind the curtain of consciousness itself. Now, I want to address something that some of you might be thinking. If sleep paralysis is so well understood, if scientists know exactly what's happening, why can't we cure it? Why can't we prevent it completely? The answer is complicated. First, as we've discussed, sleep paralysis isn't really a disease or disorder in itself. It's a malfunction of normal sleep processes. The same mechanisms that cause sleep paralysis, REM atonia, the transitions between sleep stages, are essential for normal healthy sleep. You can't just turn them off without causing other problems. Second, the brain is incredibly complex. Even though we understand the general mechanisms of sleep paralysis, we don't have precise control over those mechanisms. We can't just flip a switch and ensure that your brain always exits REM sleep at exactly the right time. We can reduce risk factors, we can treat underlying conditions, but we can't guarantee that sleep paralysis will never occur. Third, in many cases, sleep paralysis doesn't require treatment. Remember, about 30% of people will experience it at some point, but for most people, it happens rarely, maybe once or twice in a lifetime. It's terrifying when it happens, but it doesn't cause physical harm and it doesn't recur frequently enough to require medical intervention. For the smaller percentage of people who experience frequent sleep paralysis, treatment focuses on addressing underlying causes like sleep deprivation, irregular sleep schedules, stress, or sleep disorders like narcolepsy. In rare cases where sleep paralysis is frequent, severe, and significantly impacting quality of life, medications can be used. Some antidepressants, particularly SSRIs that affect serotonin systems, can alter REM sleep and reduce sleep paralysis frequency. Other medications that suppress REM sleep can be helpful, but these approaches are typically reserved for severe cases because they come with side effects and because suppressing REM sleep too much can cause other problems. REM sleep is important for memory consolidation, emotional processing, and overall brain health. You don't want to eliminate it completely. This brings us to an important point about the future of sleep paralysis research. As neuroscience advances, as we develop better techniques for studying the brain, as we gain more precise understanding of how consciousness works, we may eventually develop better treatments. Maybe we'll be able to identify specific neural circuits that, when targeted with precise interventions, could prevent sleep paralysis without disrupting normal sleep. Maybe we'll develop psychological techniques that are more effective at reducing the fear response during episodes. Maybe we'll discover genetic factors that could be addressed therapeutically. But for now, the best approaches remain lifestyle modifications, education, stress management, and treating underlying sleep disorders. It's not a perfect solution, but for most people, it's enough. And the simple act of understanding what sleep paralysis is, knowing that it's not dangerous, knowing that it's temporary, can transform the experience from something traumatic into something merely unpleasant. Let me share one more perspective on sleep paralysis that I find particularly interesting. Some philosophers and consciousness researchers have argued that sleep paralysis, despite being terrifying, is actually a valuable phenomenon from a scientific standpoint. It's one of the few naturally occurring altered states of consciousness that happens to ordinary people, that doesn't require drugs or meditation or special techniques. Sleep paralysis provides a window into how consciousness works, how perception works, how the brain constructs reality. By studying sleep paralysis, scientists have
Learned about the neural basis of hallucinations, the mechanisms of body awareness, the systems that create our sense of agency and control, the circuits involved in threat detection and fear responses. Sleep paralysis has taught us about how different aspects of consciousness, like awareness, perception, and motor control, can be dissociated from each other. It's shown us that what we think of as unified conscious experience is actually made up of many separate processes that usually work together seamlessly but can be separated. In other words, your terrifying experience of sleep paralysis has contributed to scientific understanding of consciousness. Thousands of people describing their sleep paralysis experiences, participating in research studies, allowing scientists to study their brains during episodes. All of this has advanced human knowledge. It's a small consolation when you're paralyzed and seeing demons, but it's worth noting that this phenomenon, as unpleasant as it is, has value beyond just being a scary story. So, where does this leave us? We've journeyed deep into the neuroscience of sleep paralysis. We've explored the mechanisms, the brain regions involved, the neurotransmitters, the evolutionary history. We've looked at the cultural interpretations throughout history. We've examined the psychological impacts. We've discussed prevention and coping strategies. We've touched on cutting-edge research and future directions. What can we take away from all of this? First, sleep paralysis, while terrifying, is not dangerous. It's a temporary glitch in your brain's sleep systems. It will pass. You will be able to move again. You are not dying. You are not being attacked by anything real. Second, sleep paralysis is common. If you've experienced it, you are not alone. Millions of people have experienced the same thing. You're not crazy. You're not broken. Your brain simply experienced a well-documented neurological phenomenon. Third, understanding what's happening can reduce the trauma. When you know that the demon you're seeing is a hallucination generated by your overactive amygdala, that the pressure on your chest is caused by breathing irregularities during partial REM paralysis, that the whole experience is your brain trying to make sense of a confusing situation, it becomes less terrifying. Knowledge is power, even when you're paralyzed. Fourth, you can reduce your risk. By maintaining good sleep hygiene, managing stress, keeping a consistent sleep schedule, and addressing underlying sleep disorders, you can significantly reduce the likelihood of experiencing sleep paralysis. Fifth, if you do experience it, remember to stay calm. Remind yourself it's temporary. Focus on small movements, and accept that you're temporarily paralyzed rather than fighting it. These strategies can help the episode pass more quickly and reduce the intensity of the experience. But perhaps most importantly, sleep paralysis reminds us of something profound about being human. Our experience of reality, our sense of self, our perception of the world, all of it is constructed by our brains. We walk around thinking we have direct access to reality, that we see the world as it truly is.
But sleep paralysis reveals that our brains are constantly creating, interpreting, and constructing our experience. The demons aren't out there in the world, they're in here, in the neural machinery of consciousness. And that's simultaneously comforting and unsettling. It's comforting because it means there's nothing actually trying to harm you during sleep paralysis. The threat isn't real. It's unsettling because it reveals that even our most vivid, most convincing experiences can be illusions. If your brain can create a demon that seems absolutely completely real, so real that you'd swear it was there, what else might it be creating? How much of your everyday experience is accurate perception versus brain-generated interpretation? These are questions that philosophers and neuroscientists are still grappling with. Sleep paralysis doesn't answer them, but it certainly makes them more urgent. In the end, sleep paralysis demons are the price we pay for having complex brains with elaborate sleep systems, sensitive threat detection, vivid imagination, and the ability to consciously experience the world. They're glitches in the most sophisticated piece of machinery in the known universe, the human brain. They're evolutionary leftovers, our threat detection system misfiring in a safe environment. They're neurological accidents, brain processes happening out of sequence. But they're also windows into consciousness itself, revealing the constructed nature of everything we experience. They're reminders that reality isn't as straightforward as it seems, that perception is an active process, that the boundary between dreams and waking is thinner than we'd like to believe. So the next time you hear someone dismissively say that sleep paralysis demons aren't real, that they're just in your head, you can tell them that yes, they are in your head. That's exactly the point. And that's what makes them so fascinating and so terrifying. Because if your head can create something that feels that real, that convincing, that present, what does that say about everything else you experience? What does it mean for something to be real if your brain can create experiences that feel real but aren't? These are questions that philosophers and neuroscientists are still grappling with. Sleep paralysis doesn't answer them, but it certainly makes them more urgent. In the end, sleep paralysis demons are the price we pay for having complex brains with elaborate sleep systems, sensitive threat detection, vivid imagination, and the ability to consciously experience the world. They're glitches in the most sophisticated piece of machinery in the known universe, the human brain. They're evolutionary leftovers, our threat detection system misfiring in a safe environment. They're neurological accidents, brain processes happening out of sequence. But they're also windows into consciousness itself, revealing the constructed nature of everything. They're reminders that reality isn't as straightforward as it seems, that perception is an active process, that the boundary between dreams and waking is thinner than we'd like to believe. So the next time you hear someone dismissively say that sleep paralysis demons aren't real, that they're just in your head, you can tell them that yes, they are in your head. That's exactly the point. And that's what makes them so fascinating and so terrifying. Because if your head can create something that feels that real, that convincing, that present, what does that say about everything else you experience? What does it mean for something to be real if your brain can create experiences that feel real but aren't? These are the questions that sleep paralysis forces us to confront. And while I can't offer you a way to never experience sleep paralysis again, while I can't guarantee that you'll never wake up paralyzed and terrified, I can offer you understanding. I can offer you knowledge. I can offer you the comfort of knowing that millions of others have experienced the same thing, that science has studied it extensively, that it's not supernatural, it's not dangerous, and it's not a sign that something is wrong with you. Your brain is doing what human brains sometimes do, creating vivid experiences from the raw materials of neural activity. You're experiencing one of the most fascinating and disturbing quirks of human consciousness, and now you understand why. The demons in your room aren't coming from hell or another dimension. They're coming from the most complex, most powerful, most mysterious thing in existence, your own mind. And honestly, when you think about it, that's almost scarier than any supernatural explanation, because it means that the capacity for horror, for terror, for creating entities that seem to want to harm you, all of that exists inside you, waiting for the right neurological conditions to manifest. You don't need to be possessed. You don't need to be cursed. You just need to wake up at the wrong moment during REM sleep, and your own brain will generate demons for you. Sleep well, and remember, if you do wake up paralyzed, if you do see something in the darkness, if you do feel that crushing weight on your chest, it's not a demon, it's you. It's your amygdala, your visual cortex, your motor cortex, your neurotransmitters, your brain trying desperately to make sense of a situation that doesn't make sense. It's your consciousness, that miraculous phenomenon that emerges from billions of neurons firing in precise patterns, temporarily glitching out. It's your mind showing you what it's capable of. And while that might not make the experience any less terrifying in the moment, maybe, just maybe, understanding the science can help you face the demons, knowing that they're nothing more than shadows cast by your own consciousness. Terrifying shadows, yes, but shadows nonetheless. And shadows can't hurt you, even when they seem absolutely, completely, undeniably real.